let's do some examples involving all the different angles of a circle. Now, first thing you have to ask is, what kind of angle am I looking at? So for this first example, what kind of angle are we looking at? Well, it's an inscribed angle. How can I tell? The vertex is on the circle. So the measure of angle ABC, an inscribed angle, is half the measure of the intercepted arc. Okay, so then, well, what's my intercepted arc? I'm told it's 100, 1/2 of 100, which is 50 degrees. So X is 50 degrees. That's the measure of that angle. Okay, let's look at our next example. Now, with this example, we've got two chords intersecting in the middle of a circle. So this is a chord type angle, right? Now, okay, how do I find that? The measure of angle BED, which is X, is equal to the average of these two arcs, right? Is equal to arc BD plus arc AC divided by 2. Okay, we know that 70 plus 170 over 2 is 240 over 2, which is 120 degrees. Okay, not bad. So then X is 120 degrees. Let's look at a few more examples. Okay, again, I'm going to start by asking, what kind of angle am I looking at here? Well, I have an external angle, and here I have a secant and a secant. Now remember, for secant angles, it's so X equals the big arc minus the small arc divided by 2. It's not the average. It's the big minus the small divided by 2. Well, here I have the small, but I don't have the big. How can I find the big? Well, this is a diameter, right? It's clearly a straight line through the circle, so it's a diameter. So that means this whole arc right here is 180 degrees, meaning that 20 plus 100 plus this equals 180. So this then is 60 degrees. Okay, if you need to take a second and think through that, take a second. But that's 60 degrees. So now I have my big 60 minus my small 20 divided by 2. 60 minus 20 is 40 divided by 2 is 20. So that means X is 20 degrees. Another example, we've got a quadrilateral here. Remember, so we could do a lot of, we could do a lot of things, but remember, we have that theorem that states that the opposite angles of a quadrilateral are supplementary if they're inscribed in a circle. So the opposite angles of an inscribed quadrilateral are supplementary. So that means that angle C is 180 minus 117, and angle D is 180 minus 102. Pretty straightforward. C then is 63 degrees, and D would be 78 degrees. And if we add all those up, it equals 360, which is the sum of the interior angles of a quadrilateral. Not too shabby. Okay. Whoa. We got a lot going on here. Here, I have a few things going on, right? I have some inscribed angles and all of that. Now, and I have an arc length over here with 92. Now, there's a few things that we can think about here. Here's what I want you to think about. MP is a diameter. So that tells me a lot of things, right? MP being a diameter means that this whole circle is cut in half. So that means that this LM plus LP is 180. So that means the measure of this arc is 88 degrees. Okay, what else can I divine from this? Well, since this is a diameter, that means angle N is a right angle. Okay, that might be important later, I don't know. What else do I know? Well, I know that this angle is 68 degrees, right? PLN is 68 degrees. Remember, the angle is half of the intercepted arc. So that means arc PN is twice of angle PLN. So 68 degrees, twice of that is 136 degrees for this. And then, okay, great. Now, what else can I learn from this? Well, now I have all the pieces of my circle except for this part right here. And we know that this even equals 180, but this MN is, you could add all these together and do all of that minus 360, or 180 minus 136. So MN is 44 degrees. Okay, now using that, I can find all of the angles, I should be able to, or at least find most of them, of the interior, right? Because angle M, this intercepts this PN right here, right? 136. So PMN is equal to half of 136, so that's 68 degrees. Angle P, right, MPN, angle MPN is half of 44, so that's 22 degrees. Okay, so I just found a whole bunch of stuff. I'm not even sure if I found everything I needed to. I guess we could also say that we know this angle LNP is half of 92, so that's 46 degrees. Which, because these two add to 90, that would make this 44 degrees. I think that's most of it. Okay, so let's look. Measure of angle M, right? We just found that. That's 68 degrees. LNP, we just found that, right? Half of 92 is 46 degrees. MPN, that's half of 44 degrees. That's 22 degrees. And the measure of arc LM, we also found that. The measure of arc LM is 88 degrees. So if we take a second and just look at what the triangle gives us, we can find all of these different pieces. Okay, here, this is kind of an interesting one. We have a tangent, what looks to be a tangent, and a chord. So remember, this with a chord and a tangent is, well, let's just take it step by step. I have X, I have this as 120. That means I know that this is 360. Not 360, sorry. I know that these two add to 360, so I know this is 240 out here. And, well, that actually doesn't matter because I know that for a tangent and a chord, that this angle is half the angle of the intercepted arc. It's like an inscribed angle, right? So it's half the angle of the intercepted arc, that's 120, so that means X would be 60 degrees. It's half of 120. X equals 120 divided by 2. So there you have it. Because the measure of angle CBA is equal to 1/2 arc AB. Okay, I think we've got one more example. Boom. Find the measure of these two arcs. We know that the measure of angle P is 44 degrees. Okay, now, If you remember that for tangent, because this is two tangent lines, that for a tangent angle, remember that the measure of angle P is equal to it's equal to 180 minus QR, right? Minus the small arc, supplementary with the small arc. That's the measure of angle P. So, well, we could just flip that around and say that QR is equal to 180 minus the measure of angle P. So QR then is equal to 180 minus 44, or 136 degrees. If that's 136, well then this is just 360 minus 136, which is 224 degrees. 224 degrees. There you have it. That's the measure of the two arcs. Now, if you didn't remember, and you just remembered that this was big minus small divided by 2, you could still find it if you just remember that the big, right, that the big arc is equal to 360 minus the small arc. And you could still find all of that. Okay, so there you have it. Those are some examples, just applications of all of those different properties of circles that we learned earlier. Hope that was helpful. See you in the next video.